Okay, in lesson 4B, we're going to work with composite functions. This might be your first experience working with these. That's when a function is embedded into another function. Um, what you want to remember, it's not like you're not adding the function, subtracting, multiplying, or dividing. The most common one people confuse is multiplication. Um, if you look at the ones that have the slash through it, this is f of x, and you know you're finished working with f of x because you close the parentheses, plus a separate function, g of x. You close the parentheses. Those are two completely separate functions that you're trying to pull together. Um, Subtraction, same way. Constant times a function. You've closed the parentheses that opened up f of x. In the multiplication, you have f of x, you close the parenthesis, and you want to multiply that with g of x, and you close the parenthesis. So those are operation functions. When you're talking about composite functions, you want to start with the most inward parentheses, and you want to work your way to the outside. So I put a pretty long one in here. This is f of g of h of I of x. You only have one x here, and that's the inwardmost parentheses. So you start with x, you plug it into the I function, you get an answer. You take that answer, you plug it into the h function, take that answer, plug it into the g function, take that answer, plug it into the f function, and then you're done because you have closed the parenthesis after the f function. So the difference between composite functions and the operation functions you were working with when you were evaluating is that you haven't closed your parentheses yet, and you need to plug it into the next guy until it's all over. So let's look at some examples. Here we have f of x is 3x minus 7, and a separate function, g of x, is 5x squared plus 1. Now, I'm going to work with numbers to begin with just to kind of help you get an idea of what's going on. So if I asked you from lesson 4a to evaluate f of 2, this tells you to take this value 2, it's what's in parentheses, plug it into the f function, because that's the one it's telling you to work with. You get 3 times 2 minus 7, which is 6 minus 7, which is negative 1. So we would say f of 2 is negative 1. G of 2 tells you to take the innermost parentheses 2, plug it into the g function, because that's the one it's telling you to work with. That's 5 times 2 squared plus 1, which would be 20 plus 1, which would be 21. Okay? All right, so now I have these two answers. And so working with the number concept and not working with just generic functions, we'll do that in a second. If I tell you to find the composite function f of g of 2, then you are going to have to start with the 2, plug it into the g. Well, we just did that and we got 21. So this would be the same thing as f of 21. Okay, because that's what g of 2 is. And then f of 21 would be 3 times 21 minus 7, which is 63 minus 7, which is 56. So we would say f of g of 2 is 56. You got the g of 2, and you took that answer, and you plugged it into the f function. Now that's completely different than g of f of 2. So clearly these guys are not commutative. So f of 2, we did that up there, gave me negative 1. So we're going to take that answer, plug it into the g function. So we're going to look for g of negative 1, and that's going to be 5 times negative 1 squared plus 1, which is going to give me 6. So we would say g of f of 2 gives me 6, which is different than f of g of 2 that gave me 56. Now you can plug things back into themselves. All right, for example, here we have f of 2 gave me -1. So this whole amount we've already figured out. And we can plug that into f again. So we're looking for f of -1, which is going to give me -10. So you always start in the innermost parenthesis, plug that guy into the one next to him, get that answer, plug that whole answer into the one next to him, and you keep working outward. All right, let's try another one. Let's try f of 4. So we're going to take 4, we're going to plug it in for x, because that's what we're replacing. So we have 14 plus 3 times 4 squared. So that's 14 plus 3 times 16. We've got to follow our order of operations. That's going to be 14 plus 48, which is going to give us 62. G of 4 would be to take 4, plug it into the g function for x, and that's going to give us 2. Now, just a little note, it's not going to give us plus or minus 2 because the square root was already in the problem. Keep in mind when we did quadratics a couple units ago, when you put the square root into the problem, that's when you need the plus or minus. If the square root's already there, you got to take the symbol that it comes with, and this guy was positive. All right, so now let's see what we have. This says f of g of 4, so that's telling us to take 4, plug it into the g function, which we know is 2, and then take that answer 2 and plug it into the f function. So that's going to be 14 plus 3 times 2 squared, which is going to be 14 plus 3 times 4 is 12. So that would be 26. Now, completely different is f of 4 plugged into g. So we know f of 4, we just figured that out, is 62. Take that guy, and he gets plugged into the g function. So that would be the square root of 62. Okay. F of 4, you'd want a calculator for this, but all that's saying is plug 4 into the F. And when you do that, you get 62, and then plug 62. I'm not going to work this out because 62 squared is a huge number, but you would just grab your calculator, plug 62 in, square it, times 3 plus 14. All right. Now, when you're working with numbers, that's not so bad. You have your calculator to help you. But sometimes composite functions stay with x, and they just want you to come up with the expression. They don't want you to come up with an exact answer. We're not working with plugging numbers in at this point. So if you look at this guy says, all right, h of g of x. So g of x is the innermost function. That's this guy right here. And the guy next to him is h. So we're going to plug him in for x of the h function. So that's going to be 12 minus 2 times the quantity 3x plus 5 squared. Okay, so 3x plus 5 squared is 9x squared plus 30x. That's what we did last unit, plus 25. So at this point, we're just going to clean it up. So that's 12 minus 18x squared minus 60x minus 50. Combine our like terms, we're going to get negative 18x squared minus 60x minus 38. Okay, all right, h of x is our innermost function on this guy. We need to plug him into the f function. All right, so that's going to be 4 times 12 minus 2x squared, which is going to give you 48 minus 8x squared. And then we're going to take that answer that we just got and plug them into the g function. So then that would give us 3 48 minus 8x squared plus 5. Okay, so 48 times 3 is going to give you 144 minus 3 times 8 is going to give you 24x squared. And then we need to tack on that 5. So we're looking at 149 minus 24x squared. So you can see by changing the order, it completely can change your answer. So this is f of h of f of x. So we're going to start with our innermost function f of x, plug it into h. So that would give us 12 minus 2 times the quantity 4x squared. So that's 12 minus 2 times 16x squared. So that is 12 minus 32x squared. And then we're going to take that answer, which represents this whole thing, and plug it into f, which f tells you it's 4 times x. So it's 4 times 12 minus 32x squared. And so our answer here would be 48 minus 128x squared. So that's what we would be looking for there. All right, here's another example. This one has a fraction in it. So f of g of x, take g, plug it in to f. So that's going to be f of 3x plus 1. So just like we evaluated where you plugged a number into the function, you can plug a function into a function. So that is going to be 2 plus 3x plus 1 over 5, which gives us 3x plus 3 over 5. Now that's different. This one is g of f, so that's going to tell you to take the f function and plug it in to the g function. So that's going to be 3 times 2 plus x over 5 and then plus 1. So that's going to give us 6 plus 3x over 5 plus 1. So we're dealing with fractions. The 1 becomes 5 over 5. So you get 11 plus 3x over 5. Okay, you can work with f of f. This one's going to get ugly because we're going to plug a fraction into a fraction. But you take the f function and you plug it back into itself. So 2 plus x over 5. So it's going to be 2 plus x over 5 over 5. So that 2, you got to get a common denominator, is going to become 10/5. So then you get 12 plus x over 5 divided by 5 is, we don't divide fractions, we multiply by the reciprocal. So instead of dividing by 5, I'm going to multiply by 1/5. And my final answer will be 12 plus x over 25. All right. So hopefully this helped you to be able to work through the activity. Um, when you're working with numbers, you can just plug them in and then take that answer and plug it into the next piece. When you're working with functions, it gets a little bit harder to keep up with, but the process is the same and just take it step by step.